the idea behind this is that you want to assign a particular number to the sum of natural numbers. S is equal to 1 plus 2 plus 3 plus 4 plus 5 plus 6. And if you remember from your freshman year, this is an arithmetic sequence with a common difference of 1 and a first term of 1, which means I can write it in sigma notation as the sum from n equals 1 to infinity of n. And if I want to assign a particular value to this, it's not really a sum in the way of adding up an infinite number of terms. Basically, if I added up an infinite number of terms that are increasing, I should get infinity. But infinity is just an idea, it's not a number. So maybe there's a better way we can approach this. I'm going to start with two other infinite sequences that will help us derive this. The first one is the alternating 1 minus 1 plus 1 minus 1 plus 1 minus 1, and so on. And with that first one, I want to essentially look at it and try to figure out what this is going to be equal to. Well, if I pair these together, I essentially get 1 minus 0 plus 0 minus, or just 1 plus 0 plus 0 plus, I get 1. And that's what happens if I pair the ones after the 1. So I leave the initial 1, but then I pair every other 1 after that, and I get 1. However, if I pair them starting with the original 1, I get 0 plus 0 plus 0 plus 0. I get 0. So which is it? Well, we actually say it's both. It's actually, we take the average of the two of them and say that the sum is actually 1/2. That way it's just between the two different ways that we can pair them. And this result is probably the most controversial of all of these, but that's the one that forms the basis for what is going to become the sum of the natural numbers. So I'm going to pair that off and highlight that. We're going to use this result here in a second, and then we're going to move on to another one that will help us build this result. So the next one is to look at this sequence. I'm going to call this S2, and this is equal to 1 minus 2 plus 3 minus 4 plus 5 minus 6, and so on. And what I'm going to do with this is I'm going to add it to itself. But I'm going to add it to itself in a way that shifts it. So shifting meaning 1 minus 2 plus 3 minus 4 plus 5 minus 6, and so on. And what I get is 2s2 is equal to 1 minus 1 plus 1 minus 1 plus 1 minus 1, and so on, which we know that that sum is equal to 1/2 because we already established what that was right up above, which means that S2 is equal to 1/2 divided by 2, or 1/4. I'm going to group that off, and we're going to save that result. The final step in this is to build our original sequence using S2. So to do that, I'm going to take S, which is 1 plus 2 plus 3 plus 4 plus 5 plus 6, and I'm going to subtract S2. And in subtracting S2, which I'm going to take this highlight and just kind of highlight S2 so you can see it, means changing all the signs. So -1, +2, -3, +4, -5, +6. And if I do that, what I get is S minus S2 is equal to, those are going to cancel 4, those are going to cancel 8, those are going to cancel 12, plus 16, plus 20, if the pattern continues, and it does, and so on. Well, factor a 4 out, and I get 4 times 1 plus 2 plus 3 plus 4 plus 5, and so on, which is really the same as 4s, because that entire sequence is just S. So I have S minus S2 is equal to 4S. Well, if I move things around, I would get -3S is equal to S2. But we said up above that S2 is equal to 1/4, which means that if I divide both sides by 3, S is equal to -1/12. And we know that S is just 1 plus 2 plus 3 plus 4 plus 5 plus 6, and so on. That is equal to negative 1/12.